Alvaro Izquierdo, and I'll be talking about the abstract and the conclusion about the steel project. So, without a building that can remain in place, there is no ethical reason to construct such a thing. So the long-term and the short-term effects of the environment are considered as well. Uses of steel are vast and can be incorporated in many materials used in constructions nowadays. For this reason, we include a topic on what steel can be used for and how it can be used in the past.
Today my group and I will discuss high-strength steel, as well as many factors that make it such a highly used material today. An introduction to steel will be discussed, as well as some history regarding steel. Some of the topics that will be discussed include properties of steel, mechanical tests, quality control, and even construction techniques of high-strength steel. Steel can behave a certain way depending on environmental factors or even factors that we bring upon it. The common construction behaviors of steel are introduced so that a more in-depth understanding of behaviors can be understood.
Hello everyone, my name is Edmund D'ottavio. I will be presenting the introduction for steel as a material of construction, short and long-term analysis under different environments. I put together a short little slideshow here that I will be narrating. Please follow along. Hope you enjoy. In this presentation, we will speak about origins of iron and steel, including a brief history, and the notable people in steel advancements, including Henry Bessemer and Andrew Carnegie. We'll then talk about the modern day steel industry, touching on specialty steels, high-strength steel, and the challenges and growth that the industry faces. Finally, I'll go over the report and rationale and the future of the steel industry. Origins of iron and steel. The use of steel can be seen as far back as 4,000 years ago, displacing softer metals like bronze. By the 1600s, iron had been refined, but still had low strength and quality. In 1856, Henry Bessemer developed a way to increase the strength of iron using oxygen to reduce the amount of carbon within the iron, thus creating steel. The earliest modern uses of steel can be seen in the shipyards in the mid-1800s. The U.S. railroad expansion in the mid-1800s led the way for an explosion in steel production. Capitalists at that time saw this as a huge opportunity, including Andrew Carnegie. Carnegie owned and operated Carnegie Steel and merged with James L. Steel later on to form the U.S. Steel Corporation. Carnegie built the first skyscraper in 1895, being the first steel frame building in Pittsburgh and steel cage building in the world. Following World War I, domestic steel production was back in full swing. New York City was at the very center. The skyline was changing. Iconic structures like Rockefeller Center, the George Washington Bridge, Waldorf Astoria Hotel, and of course the Empire State Building were all emerging at this time. The Empire State Building used over 60,000 tons of steel alone, making it the tallest building in the world. Post-World War II, the second construction boom had hit. With it came new methods of steel construction. The use of steel truss domes and long-span roof systems became a popular choice for stadiums and large industrial facilities. The Astrodome and Superdome are two great examples during this time. The modern-day steel industry is changing based on engineering demands and technological advancements. Steel materials that were rare or non-existent in the early 1900s, such as stainless steel and galvanized, are now common production and easily sourced. Production of advanced high-strength steels, designed with unique properties, are being fabricated today to meet the construction demands of these massive structures. Trends in steel coincide largely with the construction industry, adapting as it becomes necessary. The modern-day global steel industry production by country is shown by the pie chart on the right. The construction industry growth is strong in the public and private sectors, including infrastructure, municipal, residential, and commercial. The construction industry consumes over 50% of the world's steel. As the global population increases to over 1 billion at 2030 and 9.8 billion by 2050, we can forecast that steel production is going to have to rise in order to meet those demands. Finally, the report and rationale. Engineers and architects have many choices of materials when it comes to the construction of buildings and structures. The use, cost, aesthetics, location, and availability of materials all play an important role on selection. We will analyze steel as a construction material under different environments with respect to the properties, uses, construction methods, sustainability, and behaviors. The The research conducted will support the analysis that steel in construction is central to the way our society develops and changes. With advances in production and construction methods, steel will be an invaluable material for the construction of our roads, buildings, and infrastructure for generations to come.
How you doing, guys? My name's Lewis. I'm going to talk to you a little bit about the properties of steel. Steel has been around for a very long time, especially in the construction industry. It's said to be one of the most important building materials in the world. Steel has many properties. Ones that stand out are that it's durable, it's very formable, and it has great thermal conductivity. To know steel, we must first understand iron. Iron's also been around for a very long time. Today's technology, steel can be made very specifically depending on how it's going to be used. Some steels can be harder than others. Some steels might have a different melting point. Some steels may even be a little more flexible. It all depends on what kind of job you're trying to do. So according to the American Iron and Steel Institute, also known as AISI, there are several different categories that the term steel falls under. There are carbon steels, alloy steels, stainless steels, and also tool steels. So carbon steels are made from a combination of iron and carbon. Changing the amount of carbon applied to making steel can really change the final product. Typically, the higher the carbon level, the stronger, but also the frailer the steel can be. Steels that are made with lower amounts of carbon are also referred to as route steels, which are typically good for welding. The low strength keeps the cost very low. Steels with medium carbon levels have a decent toughness, but can be made harder by quenching. Alloy steels get their names because they are made with small percentages of a few different types of metals, with the exception of iron. When aluminum, for example, is added, it can dress the steel better, make it a little more attractive. When magnesium is added, it can become very strong. As we all know, steel is very strong, probably one of the strongest materials on Earth. When it comes to strength from this type of metal, don't let size fool you. Often the strongest types of steel are those that are mixed together. Steels that are made up of one component are usually not that tough. To this day, the strongest steel is called tungsten. It has a strength rating of 1500 megapascals and one of the highest melting points. On the job site, you'll run into all different types of steel, especially when it comes to reinforcing concrete. Steel and concrete have a very good relationship. They actually help each other become stronger. Concrete has good compressive properties, but not very good tensive properties. Steel, on the other hand, very good tensive member, but has decent compressive properties. With these two materials bonded together, they are extremely strong and can withstand incredible amounts.
Hello everyone, my name is Lou Valencia. I'm going to be talking to you guys briefly about the uses of steel in this presentation. So just jumping right into it, basically the main uses of steel in early times was for warfare. Spanish smiths used to make swords for the Roman army using steel. Japanese smiths used a special kind of steel to make katanas for their samurai. Outside of weaponry, there were very limited uses for steel, but the Romans were able to utilize wood steel to make basic construction tools such as hooks, harness rings, adzes, which is kind of like an old school axe, saws, and shovels. Just summarizing it up, the earliest uses for steel in the early days was for weaponry and basic construction tools. Fast forwarding into modern times, and when I say modern, around several decades or so, you'll find that steel almost has an infinite amount of uses. To list them all would be a little bit too long, so I'm going to talk to you guys about the main industries that are super involved in steel utilization. Let me start with the transportation industry, which uses about 16% of global steel production. This encompasses vehicles and related infrastructure. Just talking about vehicles quickly, we all know that steel is used heavily in vehicles. Ship hulls use it for decreased weight and corrosion resistance, airplanes for landing gears, and trains for their bogies. Bogies are the underneath components, which include wheels, motors, axles, and bearings. Pretty much anything the train needs to move is made out of steel. So basically, steel in the transportation industry is used for its high strength to resist significant forces experienced by these vehicles on a daily basis. Moving on from transportation is the energy sector. Structurally speaking, steel is super involved in the creation of these structures. Let's take, for example, the Hoover Dam, which used about 151 million pounds of steel to make. That included reinforcement steel, structural steel, and plate steel. Outside of the structural uses, you could use it for energy distribution, steel pipelines that move natural gases and oils, electricity via pylons and steel reinforced cables that you might see on the side of the road, even transformers that take electricity from power plants have magnetic cores to lower the voltage that's coming from the electricity coming from power plants into our homes. So those are some examples of steel usage in the energy sector. And lastly, probably the most relevant industry to use steel is the construction industry, which uses more than 50% of global steel product. Pretty much every building uses some type of structural steel and also rebar, which accounts for about 44% of the building's mass. Structural components, non-structural components such as HVAC equipment, ducts, rail fixtures, stairs also use steel in some way, some form or another. So steel's affordability, abundance, and highly valuable intrinsic qualities such as the high strength and the 100% recyclability make it one of the best, if not the best, material to use for construction. So yeah, there you guys have it. Again, biggest industries to use steel: transportation, energy, and construction. If we didn't have steel, it'd be hard to imagine us as a society being as advanced today as we are. So yeah, that's about it. Thank you, everyone. Please enjoy the rest of the presentation.
Hello everyone, my name is Yoriel Camejo, and today I will be going over construction methods of steel, part 1. So, steel is one of the most important modern construction materials due to its versatility. Its low cost and durability, paired with the abundance available, has increased the popularity of the material over the last couple decades. The most used method of steel construction is reinforcing. So concrete slabs, for example, are supplemented with steel to further enhance and strengthen the foundation. So as we see in this picture, there are steel bars laid out and concrete is being poured in, and once everything is cured and dried, it will be a lot stronger than if it were just a concrete by itself. Because steel is strong in tension and concrete is strong in compression, they make a perfect pair. Among other material construction methods, there is the structural steel design. More importantly, we're going to be talking about its simple design aspect, which is the most traditional approach, and it is still commonly used. It is assumed that no moment is transferred from one connected member to another. The resistance of the structure to lateral loads and sways is usually ensured by the provision of bracing. So proper bracing of each member will ensure that everything is connected and everything is basically just one structure, which enhances its strength, and that will be what the video is about today.
Hello, my name is Lorio, and today I'm going to be talking to you a little bit about construction methods. So in construction, there can be a variety of different construction methods, but there are typically 4 main ones. Those 4 main ones are going to be design and build, engineering, procurement, construction managers, whether it be at risk or normal, and the integrated project delivery. Those are different. There are different names for those. It could be a whole bunch of different names, but those are generally the most common ones used in the field. Within each of those construction methods, the reason why there are different ones is because basically different owners have different types of decisions to make and different types of visions about their project. So going with different construction methods allow for different opportunities to either save money or to save materials or to increase the amount of profit you can make from a certain amount of job. So there'd be a multitude of different things that you would normally not have with other construction methods. It also depends on the total budget of the actual project and whether or not the construction manager is involved, whether as an architect or contractor or simply just giving advice to the owner. So each of those different methods provides a different benefit and different negatives to each and to the owner. Furthermore, the majority of the times with these methods, the contractor is simply receiving orders from the architect. The architect is usually the main person in charge, the main person leading the entire project, with the overall owner and all the subcontractors as well. So typically it works through a chain of command, and it would be the owner, the architect, sometimes with a subcontractor on the side, but majority of the time it would be owner, architect, and then going trickle down to the subcontractors if necessary.
Hello, my name is Hiram Alonso. I'm going to talk about the behavior of steel in construction. Basically, there is two factors that affect behavior of the steel. It's alloy and the shape. The behavior of steel is going to change due to the content of carbon and the addition of other metals to the composite. Carbon generally increases the hardness and lightness of the iron alloy. What we call steel is an iron alloy with less than 2% carbon. This creates a material that performs very well in both tension and compression stress. Mild steel or low carbon steel is the most common alloy for modern structural steel. It has a content of no more than 0.3% carbon. This alloy also contains a small amount of other metals to improve strength, toughness, and other qualities such as resistance to corrosion. Knowing this, the other factor that affect the behavior of the steel is the shape of the piece. The most commonly used shape of beams and columns in construction is Y flange or W shape. However, we also use I-beams, channels, angles, and teeth for other applications. A member of steel is subject to lateral torsion buckling of plate, flexural torsion buckling, among other forces, but this is the most common behaviors. Lateral torsion buckling is the lateral twisting and displacement of the beam due to applied load that increases tension and compression in the flange, twisting the beam along the longitudinal axis. This can be prevented by restraining the flange on the compression since it will prevent the beam from rotating along its axis. The load is applied above the shear center to expose the beam to torsional buckling. Buckling of plates is when a compressive force express the beam wall section of the steel beam, causing the plate to buckle. This compressional stress can lead to the bending of the plate. Also, geometrical imperfections in manufacturing and fabrication of the beam can increase the chance of the plate to buckle. Last but not least is flexural torsion buckling that occurs in compression member that have unsymmetrical cross-section with one axis of symmetry. Flexural torsion buckling is the simultaneous bending and twisting of a member, and this must occur in channel or circular teeth, double angle shapes, and equal left single angles. Thank you.
Hello, my name is Michael Laltoo, and today I'll be presenting the sustainability of steel. Steel is the most sustainable construction material available in the world due to its 100% recyclability. It has a recycled content of 93% with a recycling rate of 98%, the highest of any building framing material. While other products can only be recycled into lower quality products, also known as downcycled, steel can be recycled over and over again without any loss of quality or multi-cycled. Structural steel is fabricated in facilities to stringent tolerances, then erected on-site. On-site fabrication minimizes employee travel, allowing for less community disruption and a smaller job site footprint. This also contributes to less pollution from heavy machinery and on-site fabrication activities. Steel is a long-lived material that can last for decades with little maintenance. It is resistant to most environmental conditions that are problematic, and with the right formulations and coatings, steel will not rust or corrode. Due to advances in steel manufacturing process, 98% of the raw materials used to make crude steel are converted to products and byproducts, meaning that very little waste goes to the landfill. Steel's carbon footprint has decreased by 37%, energy intensity dropped by 32%, and 45% reduction in greenhouse gas emissions. The steelmaking process boasts a 95% water recycling rate with no external discharges, resulting in a net consumption of only 70 gallons per ton. Using advanced technologies, steel plants in areas of water scarcity are able to recycle and reuse around 98% of their water. Once steel is produced, its life cycle is potentially infinite, making it an everlasting resource for society as long as it is recovered at the end of each product's life cycle. Steel is the most recycled industrial material in the world, with over 500 metric tons recycled annually, including pre- and post-consumer scrap. Reclaiming and recycling steel is easy. With its magnetic properties, steel can be extracted from both pre- and post-consumer waste and diverted back to the steel plant to be melted down and reused. Structural steel produced in the United States contains 93% recycled steel scrap on average. At the end of a building's life, 98% of all structural steel is recycled back into new steel products.
Steel has many benefits in modern day construction, although there are times where it may pose difficulties. One of the disadvantages of steel is its minimal fire resistance as compared to concrete. Steel cannot hold as much heat as concrete would, for example. Another factor to consider is that steel cannot be molded in multiple directions. Things outside of buildings that are very decorative and things like that aren't normally made out of steel. Typically they're made out of some type of concrete or maybe some plastic or something like that. As far as the future for steel, I think we're going to see tremendous improvements. As steels become lighter and stronger, we will see them used more and more in projects. Not only will the steel itself evolve and develop into a better material, but the uses for steel will also develop, maybe the methods as well. With these methods improving as well, we might see things being done faster as well on projects.
Hi, my name is Alvaro Izquierdo, and I will be talking a little bit of the conclusion of steel as a material used in construction. Steels are more durable than any other material when it's properly treated. The advantages that steel can offer in the future as the technology advances and time consumption mean that scheduling is an important part of construction. As technology advances, so will the material we use in everyday construction site. For example, lighter and more durable steel will be developed. The history is special and it's important as what is about to come in the future. The history is as special and as important as what is about to come in the future. In conclusion, steel has a potential like no other. However, it is important to consider other upcoming materials so that we can improve the way we build in construction nowadays.